Okay, how do we find the intersection point between these two? Well, you know, just to put a little context in this, how do you find the intersection point between two straight lines? If you've got like y equals 2x plus 5 and y equals negative 3x minus 7, where's the intersection point? Well, you set these two expressions for y equal 2x plus 5 equals negative 3x minus 7 and solve. So if you have straight line equations, you do this. Well, up here, now you've got y equals x squared plus 4, y equals 4 plus the square root of 2x. Okay? So we solve x squared plus 4 equals 4 plus the square root of 2x. Now, that's easy to say, but that actually turns out to be a hard, maybe even impossible equation to solve. Still, this is what we always do. We set the two equations, or the two expressions for y equal, and that'll tell us the x value that makes the y values equal. So we might have to approximate our solution because we're going to end up with a fourth order equation. That's always loads of fun. Okay? So let's go ahead and do it. Okay? Any suggestion? Good. Okay? Okay, so actually, this one turns out to be kind of easy to solve. Never mind, I said it was going to be hard. If these had been different numbers, it would have been much harder. Turns out it's very easy. Okay, subtract 4 from both sides, we get this. Square both sides. Right? So x to the fourth minus 2x equals 0. We can factor that, and we get x times x cubed minus 2 equals 0. Okay? Now I'm out of space, but I'm going to go ahead and use this blank space down here, so let's just skip around this and come down to here. Well, this is only true if x equals 0 for one thing, because you have a product of two factors that's equal to 0. The only way the product can be 0 is if one factor or the other is 0, right? So clearly x equals 0. Of course, we already knew that they both have a y-intercept of 0, 4. So the fact that they intersect at x equals 0 doesn't come as too big of a shock. Okay, that one is obvious. So that means maybe we're on the right track because we get that as part of our solution. Or x cubed minus 2 is 0. Okay? So our solution set is 0 cube root of 2. Because obviously x cubed minus 2 is 0 if x cubed equals 2. And then cube root gives us x equals the cube root of 2. Okay? And I don't know the cube root of 2 to 3 significant figures of 4. Okay? There would be cultures in which that would be something you would expect everybody to know. So I'm just as ignorant as everybody else. Okay? I bet I could approximate the cube root of 2. Okay? You know, if you cube 1.2, it's too low. If you cube 1.3, it's too high. So I'm guessing 1.2 cubed being 1.738, 728. I'm guessing around 1.22 or 1.23. Did you punch it in? You just raised 2 to the 1/3 power.
Yeah.
1 point what?
1.25.
1.25? That's ridiculous. 5/4, 125, 64ths. Yeah, that's just a little shy of 2. I should have known that. Okay. 1.23. So much for my mental interpolation skills. Okay. So approximately, but we're not going to use 1.25. We're going to use cube root of 2 in calculating this, okay? So go ahead and set up your integrals. What two integrals are you going to have? What are you going to subtract from what in order to get this area in between the two curves?